All right, well, we're on video number 7. This is a lot of work, making videos for all these problems. Let's look at number 37. So when I first look at this, you might be tempted to just jump right into using matrices to solve this, but this is actually not bad as far as, if you remember when we were solving systems of 3 equations and 3 variables using the elimination method. We would add 2 of the equations together twice, like we might add 1 and 2 together and maybe 1 and 3 together, and we would get 2 equations in the same 2 variables, and that's what we would solve, and we would get 2 of the variables, and then we would come back and get the 3rd variable using one of the original equations. Well, in this problem, right here we have 2 equations in the same 2 variables, so we can actually solve for x and z here, and then we can go back and find y using the first equation. So that's what I would do. If you really think this through, this would be the best approach here. And so you would get, if you add, and notice what happens here, when you add those equations together, the z's cancel and you get x equals -1. And so we can find z now. I'm going to use the second equation and plug in -1 for x. We get -3 plus 4z equals 9. And let's go ahead and add 3 to both sides. You get 4z equals 12, so z is equal to 3. So x is -1 and z is 3. So we just need to find y. We can use the first equation to do that. Let's go ahead and put in -1 for x. And so if you add 1 to both sides, you would see that y is 1. Okay, so our solution here is the point -1, 1, 3. Remember, you want to put the x value first, then the y value, then the z value. So that would be the easiest way to solve this. Now, if you want practice using Gaussian elimination, or if that's the way you approach this one, I'm going to go ahead and do that. But you can see that the way I just did is going to be the easiest way here. So if you're using Gaussian elimination, first you want to rewrite it in this form. Notice there's no z in the first equation, so we got to put a 0 in that position. Remember, this is our x column, our y column, and our z column. So you want to make sure the numbers are all in the right places. And so we want to get our matrix in this form where we have 1s on the main diagonal, 0s below the 1s, and numbers everywhere else. And so that's what we're trying to do here. So first of all, I already have the 1 that I need right here. And so I just need to get 0s below the 1s. So I'm going to have to multiply -2 times row 1. I'm sorry, I multiply 2 times row 1 and add that to row 2, and that way I'll get 0. And but anyway, that's going to become our new row 2 when we do that. So let's go, and I'm sorry, and we're also in the same step, I want to go ahead and multiply the first equation by, or the first row, by -3, and when we add that to the 3rd row, that's going to get a 0 in that first position. So we'll do these 2 steps at the same time here. Alright, so let's go ahead and take care of this. We'll rewrite the first row because it's not going to change. And we're going to multiply the first row by 2 and add that to row 2, and that's going to become the new row 2. So let's multiply the first row by 2. 2 times, let's see, I thought I did, oh, you know what, hold on a second, I'm going to go backwards here. So if we multiply the first row by 2, 2 times 1 is 2, 2 times 1 is 2, 2 times 0 is 0, and 2 times 0 is 0. So we're going to add this 2 and -2 to get 0 here. we'll add this 2 with this 0 here to get 2. We'll add 0 with negative 4 to get negative 4, and 0 with negative 10 to get negative 10. And so that's row 1 multiplied by 2, added to row 2, and that's our new row 2. Let me erase. Oops, hold on a second, I messed that up. I'm going to erase my marks here. Whoops, I got to be careful here. Give me just a second. Alright, so we end up with 0, 2, negative 4, and negative 10. Now we'll do the same thing with the third row. We're going to multiply the first row by negative 3, so 3 times 1 here, you get, oops, let me change colors. We get negative 3. When we add that to 3, we'll get 0. And let's multiply 1 by negative 3, we get negative 3. Adding that to 0, we get negative 3. Of course, negative 3 times 0 is 0. 0 plus 4 is 4. Negative 3 times 0 here, you get 0, and 0 plus 9 is 9. All right, now that we've got the 1 in the corner, upper left-hand corner, and then zeros below the 1s, we need to go down the main diagonal, and we're going to change that number next to a 1, or we need a 1 there. Now notice this row is full of all even numbers. In fact, 2 divided by 2 will give us the 1 we want, and we can divide the other numbers by 2, and we'll also get nice values since they're all even numbers. So we're going to take 1/2 of row 2, and that's going to become the new row 2. And so I'm going to rewrite rows 1 and 3 because those aren't changing. So taking half, dividing by 2 are the same thing. 0 divided 2 is 0. 2 divided by 2 is 1. Negative 4 divided by 2 is negative 2. And negative 10 divided by 2 is negative 5. All right, so once we get this 1 here, we want to use it to get a 0 below. And so notice here we're going to want to multiply row 2 by 3. And we're going to add that to row 3, and that'll become the new row 3. So let me rewrite the first 2 rows. So if we multiply all of these by 3, 3 times 0 is 0, we get 0 here. So when we add 3 and 0, or wait a second, that's not, I'm multiplying the wrong row there, that was row 1. We want to multiply the second row by 3. So here we're going to get 0, whoops, we're going to get 0 here, and 3 here, whoops, and negative 6 there, and negative 15 there. So 0 and 0 is 0. 3 and negative 3 is 0, which is what we were looking for. Negative 6 and 4, we end up with negative 2. Negative 15 and 9, we get negative 6. And so finally we're down to this last number. We need to get a 1 here. And we can divide by negative 2 to do that, or multiply by the reciprocal. So it would be negative 1/2 times row 3 becomes the new row 3. I'm going to rewrite the first 2 rows. And so I'm just going to divide everything by negative 2. I'm going to get 0, 0, 1, and 3. So we can write this as a system of equations now. So we have x plus y equals 0 for that first one. Notice the z coefficient would be 0, so there is no z term. On the next one, we don't have an x value. It's just going to be 1y minus 2z equals negative 5. And at the bottom there, we have z is equal to 3. So we can go ahead and substitute here into that equation, and we'll be able to solve for y. So y minus 6 equals negative 5. We'll add 6 to both sides, and we get 1. So we know that z is 3 and y is 1. Let's go ahead and plug 1 into that first equation, and you can see that x is going to be negative 1. So we get the same answer, but you can certainly see that this was a lot more work. Let's go ahead and move on to 38. All right, so we need to match each equation to its graph. So let's do that. Whoops, I'm making a mess here. So the first equation there you should recognize as the equation of a circle with a center at 2, 0. Remember x minus h and y minus k. In the second case, there is no k. We could think of it as just being 0. In fact, there's only one circle, and that would be letter I there. On number 2, we have an exponential equation. We should know what 2 to the x power looks like. It basically, when we have a base greater than 1, we're going to go through 0, 1, and have an asymptote at y equals 0. And so that's the graph of the parent function y equals 2 to the x. So the minus 1 there is going to cause us to go 1 to the right. Notice, whoops, I'm getting ahead of myself here. Notice that if you look at h and a, those are both going to have that shape that we're looking for. The thing to see here is we're going to move everything 1 to the right, and so the asymptote doesn't change. It's going to be at y equals 0, so our answer would have to be letter H. And so if you look down below at number 7, that's our other one, and if you move the graph I just drew down 1, you get A, and so that one is going to be answer A. Number 3 is going to be a parabola. It's currently in vertex form, and notice we could find the center or the vertex of the parabola. It would be at 1, 1. Basically, we normally, for a parabola, it usually is centered at, or I should say the vertex is at 0, 0. So we're going to move 1 to the right and up 1. So 1, 1 is going to be our vertex, and it does open up because of that positive number out front. And so that would have to be letter C. Notice C has got the vertex at 1, 1. Now if you look down below at number 6, that parabola, there's a minus out front. That tells us it's going to open down, and so it really makes it pretty easy. The only other parabola is G, and so that's the answer there. Now let's look at number 4 and 5. These are both absolute value functions. We know an absolute value function is the V shape, and it looks something like that. And the only thing here is on number 4, the minus 1 there is going to cause us to go right 1, and we're going to go up 1. So we need to find a V shape that's right 1 and up 1. That would be J. Notice for Y, we're looking for that same V shape being moved right 1, and that would be B. Letter B. All right, number 8 is a logarithmic function. We know logarithmic functions with a base greater than 1, in this case the base is 10, would look something like that. It goes through the point 1, 0 and has an asymptote at x equals 0. So we're going to want to move everything right 1, and so that would be letter F. On number 9, we know that when we have the cube there, that's the cube function, which has that shape, and the only one like that would be letter E. Now, process of elimination could help you here, but this is the square root function, and we know that's the ET function, looks like that. Because of that minus x, it actually goes the opposite direction, and you can see that's what we have in D. All right, let's move on to the next problem. It says find the x and y intercepts of the line and use them to graph the line. So to find x and y intercepts, I like to make an xy chart, and to find the x-intercept, we'll let y be 0. So let's plug 0 into the equation and solve for x. We'll need to add 8 to both sides. We get 2x is equal to 8, and divide each side by 2. We get x is equal to 4. So 4, 0 is the x-intercept. The y-intercept, we're going to let x be 0. This is going to be a little bit easier, actually quite a bit easier. 0 minus 8 is just negative 8, so we get negative 8 here. So let me go ahead and draw a graph, and let's put in 4, 0, and 0, negative 8, and so there's your line. On number 40, let's see, we need to find the slope first, and then write the equation of a line that goes through these 2 points. Write the equation in slope-intercept form. So slope-intercept form, hold on a second, that's this form here, slope-intercept. So basically it's solved for y. So let me erase that. To find the slope, we want to use the slope formula, and I'm going to call that my first point and that my second point. And so y sub 2 is just the y value of my second point, negative 1. Or wait a second, I got this backwards. No, y2 is negative 1 minus y1. Oh, I see what I did. I actually have this backwards the way I did it. Let me go ahead and write this or finish this out here, and I'm going to redo this. I did it backwards. So y sub 2, that's negative 1, minus y sub 1, which is 11, over x sub 2, which is 6, minus x sub 1, which is negative 3. Notice we're subtracting negative 3 there. That's going to give us negative 12 over 9. So now I've got to get caught up with what I had previously got together here. So let me erase those. So this is going to be negative 4/3. So the slope is negative 4/3. Now let's go ahead and, in order to write an equation now, we need the point slope form. That's y minus y1 is equal to m times x minus x1. And so I'm going to go ahead and use the same point as my first point. It'll be y minus 11 is equal to my slope, which is negative 4/3, times x minus negative 3. So let's go ahead and change the minus negative 3 to a plus 3. And I want to distribute on the right side. We're going to get y minus 11 is equal to negative 4/3 x. Now we need to multiply negative 4/3 times 3. When you do that, you get negative 12 over 3, or negative 4. So we get minus 4 here, and we'll add 11 to both sides. So you get y equals negative 4/3 x plus 7. All right, last problem here. We're supposed to determine the slope and y-intercept. So this is in slope-intercept form. So our slope here is negative 3/2, and our y-intercept is 0, 4. That's all we need to graph the line. So let's plot the point 0, 4. And we use the slope to get to another point. So we're going to rise negative, remember it's rise over run. That's what slope is. We're going to rise negative 3, so we're going to go down 3. And we're going to run 2, so we're going to go right 2, and we end up at the point 2, 1. And so there's your line. And that's going to be it for this video.